Coal is the world's most abundant and widely distributed fossil fuel. It has a long and venerable history. It may have been used in households and industry in China 2,000 years ago, with its industry becoming very well developed by the 12th century AD. While oil hasn't splurged into the scene of energy economics, coal was fueling the Industrial Revolution in England. In the middle 1800s, Great Britain produced just more than 60% of world's coal from around 3,000 mines. It exported around 15% of its production. The United States and Russia together accounted for another 20% of world production. By 1900, the United States had surpassed the United Kingdom in coal production, and in the 1920s, the United States consumed about half of the world's coal. Coal consumption has always been strongly tied to industrial production, and we see its sensitivity to war and the economic cycle. Thus, coal consumption fell from 1913 to 1920, largely as a result of falling consumption in the economic downturn in Germany after World War I and in Russia after the Revolution. During the Great Depression, consumption fell once again, with the United States the hardest hit. Germany by then was rearming and showed modest increases in consumption, while Russia's economy, rather isolated from the rest of the world under Stalin, was rapidly industrializing. During this time, Russian coal production increased an average of 12% per year. Almost 70% of world reduction in the 1990s was in the former Soviet Union, where coal consumption fell by half as their economies crashed. Germany's consumption fell by somewhat less than half as the country phased out high-cost mines and dirty lignite production in the former East for environmental reasons. The current production shares of the world's more prominent coal producers are shown here. Growth rates of coal production have varied over time as well. They averaged more than 4% per year from 1860 to 1913. But with a world war and a world recession, coal production in 1938 had not regained its pre-war level of 1913. World production increased more than fourfold from 1938 to 1990, but it never regained its pre-1913 growth rates except in the 70s, when the oil crisis and surging oil prices caused industry and electric utilities to switch to cheaper and politically safer coal. Coal consumption fell during the 1990s for the reasons stated. Coal prices have fluctuated rather dramatically, as shown by U.S. anthracite prices since 1800. Price, which has been adjusted for inflation, has averaged at $86.58 per ton over the last 200 years, and has varied from a minimum of $38.75 during the latter part of the 90s, when environmental concerns increasingly disadvantaged coal to a maximum of $238.88 per ton in 1814, which was the last year of the U.S. War of 1812. Anthracite prices are used instead of prices for the more widely consumed bituminous coal, since a longer time series is available. The price of lower quality bituminous coal in the United States has been between 50 and 80% that of anthracite since the World War II. These prices are the result of all economic forces that have impinged on the coal market, including the strength of the economy, the prices of factors of production, the price of other goods related to coal and technology. To better understand how production and coal prices have been determined and have evolved, we'll turn to our first economic model. Just like the allocation of other scarce resources, the allocation of coal is done either by the private sector through markets or by the government. Economists tend to favor the private sector for such allocation when the market is perfectly competitive. Property rights are well defined, externalities are few, and the subject industry does not have decreasing average costs as production increases. Let us begin by assuming a perfectly competitive model for the coal industry. In such a model, we first assume there is free entry into and exit from the industry, and sufficient buyers and sellers so that none of them can set the price. Therefore, each buyer and seller must take the market price as given. Free entry and exit assures that no buyer or seller can develop and maintain any market power. This is probably not an unreasonable assumption for the United States. As we can see in this table, the top 10 coal companies control only just more than half of the US coal production. The government owns about 20% of the US coal reserves, which it leases to companies for production. These leases are administered by the US Bureau of Land Management. In nearly all other countries, coal and all other primary energy resources are owned exclusively by the government. Although not every coal consumer is able to buy from every coal producer because of transportation costs, excessive process in one mining area are likely to bring new entrants in the form of other coal producers or other energy sources. This threat of entry by other producers is referred to as market contestability. As the coal industry is a global industry and coal is the second largest product by weight to be traded internationally, this contestability can come from large foreign producers as well as domestic companies. Such international contestability may have increased in recent years as transportation costs have decreased. These are some examples of the large coal companies around the world. The largest two of these are owned by governments, China National Coal Company and Coal India Limited. In addition, a competitive market is homogeneous, meaning that each unit of the product is just like every other. For coal, we know this is actually not quite true. Coal varies by energy content and impurities. For example, in the United States, Eastern coal has about 24 million BTU per ton, Central coal about 22 million BTU per ton, and Western coal about 18. While lignite in the Dakotas and Texas has more moisture with still lower heat content. The ranges of energy content by general coal type are shown here. This table also shows the energy content of coal, but in addition, it presents the production, consumption, and reserves of the world's most important coal producers and consumers. In a perfectly competitive model, we also assume that market participants know prices and other information relating to their market decision. For instance, coal sellers have information on coal mining technologies, output prices, and factor prices. Coal buyers, 57% of which are electricity generators worldwide, employ technologies that produce electricity and process heat from coal and from other fuels and technologies. For purposes of this model, we also assume that property rights of coal are well defined. There are no externalities, and coal mining is not a decreasing cost industry. With well-defined property rights, coal producers have exclusive rights to the coal reserves they own or lease. There are no external costs or benefits that accrue to others as the result of coal production or consumption. Again, we know this is a simplification, because in fact both coal production and consumption produce pollution, a negative externality. Also, if an industry has decreasing costs, unit costs fall as the size of the firm increases. In such an industry, monopolies will have a tendency to develop. To develop our competitive model, we divide the coal market into two groups. Buyers are represented by a demand equation and sellers by a supply equation. For the demand, the quantity purchased as a factor of production by one buyer will be influenced by the following: the price of coal, the price of substitutes to coal, such as oil or natural gas, the price of complements to coal, such as coal boilers, technology for coal use, the price of output produced, and energy policies. The quantity purchased by all buyers will also be influenced by the number of buyers in the market. For the supply, we represent suppliers by an equation in which we write quantity supply as a function of the price of coal, price of factors production of coal, such as capital and labor, price of similar goods that coal miners could produce, the price of byproducts of coal production, and coal production technology, government coal policies, and of course the number of sellers. Now let's assume that this graph represents the demand and supply of the coal industry. The equilibrium price is at $23.50, and the equilibrium quantity is 18.9 units of coal. Now let's suppose there is a shift in demand. Let the price of natural gas go to 15, for example. With gas more expensive, electricity generators might run their gas turbines less and their coal generators more. This would shift our demand curve for coal to the right. This shift would move us along the supply curve to a higher price and quantity. This movement along the supply curve to a different quantity in response to a higher price we call change in quantity supplied. While there is a change in the demand, not just the quantity demanded. In the real-world scenario, however, things are quite complicated. Now let's assume that the productivity of coal mining has decreased significantly, causing the supply to shift to the left. The movement along the demand curve changes the quantity demanded. This increases the equilibrium price and decreases the equilibrium quantity. Let's talk about how the government intervenes in the coal industry. Governments often seek to influence in markets. For example, after the Second World War, the European coal industry was contracting. To protect the industry and to protect jobs in the coal mines, the British, Belgian, Spanish, and West German governments all subsidized the industry. Although these subsidies have been reduced over time, at the turn of the century, they still amounted to more than $6 billion for Germany, Britain, Spain, Belgium, and Japan. One way of subsidizing the industry is to buy up coal in order to keep its price up. Suppose that this figure represents the West Germany coal industry. The market price with no interference is at $23.50. Suppose the German government wanted the domestic coal price to be at a minimum of $28. The government could buy enough coal to artificially inflate the price to $28. In this figure, P subscript MN is the minimum price of $28. At that price, note that the quantity demanded is less than the quantity supplied. Another way governments sometimes affect market is by setting maximum prices. If they were to set a price ceiling at P subscript MX, the quantity demand would be greater than quantity supply, resulting in a shortage. Since demanders are willing to pay more and suppliers are willing to produce more in such a case, there's a tendency for a black market to develop. Besides subsidies and setting price ceilings and floors, let's talk about taxes. Governments have various reasons for taxing energy, and such taxes will influence energy markets. An energy-producing country or state may find energy taxation a politically expedient source of revenues, particularly if a large part of the output is exported. They may tax an energy source to provide a public good related to energy consumption, such as gasoline taxes that are collected to fund roadways, for example. They may use taxes to discourage energy use, such as passing a carbon tax to discourage the use of high-carbon fossil fuels, which may cause global climate change. They may use differential taxes on energy products to influence industrial behavior, such as Europe's high import taxes on oil products and low import taxes on crude oil imports to encourage refineries to be built in Europe rather than in the oil-producing countries. Alternatively, governments may subsidize rather than tax an energy product to encourage use, such as California's subsidies on solar energy panels, or to protect a domestic industry and employment, such as Germany's subsidies to protect its domestic coal industry. Governments may subsidize energy products as part of an income redistribution scheme, such as Indonesian subsidies on kerosene to help poor residents who use kerosene for cooking and lighting. No matter what the reason is for their adoption, energy taxes and subsidies are likely to distort prices and production in energy markets. Such distortions may decrease efficiency in efficient markets, or they may increase efficiency in inefficient markets. Let's model the taxes in our competitive market. Let demand and supply in the lignite market be calculated as follows. If we want price in terms of quantity, we can find the inverted demand by separating price on one side of the equation. This graph shows the equilibrium in this market. Setting the quantity demanded and quantity supplied equal to each other, we get a price of $8 and the quantity of 2 units of coal. Now let's suppose that we put a unit tax of 1 on this product. The demand price will have to include the payment to the supplier plus the tax. The easiest way to see the intuition of the tax is to add tax to the supply price. Where this new function crosses demand is where demand price equals supply price plus the tax. both suppliers and demanders are happy with the quantity at their price. With the tax in play, the new equilibrium has a quantity of 1.33 units, a demand price of $8.33, and a supply price of $7.33. To solve for these numbers, we equated the inverse demand with the inverse supply plus tax. You may be wondering who pays for the tax. As demand price goes up from $8 to $8.33, consumers of this energy product pay 33 cents of the tax. Supply has fallen from $8 to $7.33, so producers pay 67 cents of the tax. The government revenue generated from the tax equals to the quantity times the tax. $1.33 times 1 equals $1.33. The opposite of an energy tax would be an energy subsidy. The analysis for a subsidy would be similar, but instead of adding tax to the supply, you would subtract it. Thus, consumers would pay a lower price than suppliers receive. Now, to wrap everything up, let's do a quick summary. Coal is our most abundant fossil fuel, and it fueled the Industrial Revolution. The competitive market model demonstrates how coal was first surpassed by oil and more recently by gas. Although highly stylized, this powerful model can also give us clues as to how newer fuel sources will penetrate and supplant fossil fuels. In a competitive market, we assume many buyers and sellers, a homogeneous product, both buyers and sellers with perfect information relating to market transactions, and free entry into and exit out of the industry. In addition, we assume that property rights are well defined, there are no externalities, and coal mining is not a decreasing cost industry to ensure that a competitive market allocates resources efficiently. In our competitive model, coal buyers are represented by a demand curve and coal sellers by a supply curve. Movements along these curves as the result of the coal price change are called changes in quantity demanded or supplied. Shifts of the whole curve from other variables changing are called changes in demand and changes in supply. By using basic demand and supply analysis, we improve business decisions by analyzing the effects of many events on market price and quantity, including business cycles, changes in the price of related goods, and government price supports. Quantity of coal demanded is positively related to the number of buyers, the price of substitutes such as oil or gas, and income or industrial activity. However, it is negatively related to the price of coal and complement goods such as capital. The quantity of coal supplied is positively related to the number of sellers, the price of coal, the price of byproducts of coal production, and the price of output produced using coal. It is negatively related to the price of factors of production for coal such as labor and capital, and the price of any similar product to which coal producers could switch. Technology and government policies also affect coal demand and supply, with the type of effect depending on the specific policy or technology. Governments have various reasons for taxing products, with the most predominant being to collect revenues. Energy and natural resources are often subject to special taxes beyond corporate taxes. Severance taxes are taxes on production of energy, while royalties are payments to the owner of the resource for exploiting it. Energy taxes are also applied as tariffs when energy is traded across borders, and as excise taxes when energy is sold to final consumers. Most governments tax energy products, with petroleum products, particularly gasoline, typically being the most heavily taxed. Excise taxes and subsidies have distribution effects, specifically the incidence of the tax, and also how much revenue the government collects. The elasticities of demand and supply determine who pays the tax, with the more price-elastic side of the market paying less of the tax. However, excise taxes in general are inefficient because they distort economic decisions, creating losses in welfare, referred to as the deadweight loss. The deadweight loss may be losses in consumer or producer surplus, or both.